Hello, my name is Alan Marks, and I've been a science fair judge for about 35 years. I'd like to continue talking about data collection now, and we'll start off by talking more specifically about the ranges. As I said in my previous video, you need to choose ranges for your independent variable. And let's say you have a low value and a high value. If the range that you choose is not large enough to see a difference in the value of the dependent variables, you're not going to see anything. Okay, even though, so if you look at this particular set of values, when you average the numbers of the low value with the trials of the high value, you get about the same thing. So you're not seeing any effect. If you choose a range that's larger for the independent variable, and you look at the average of the low values and the average of the high values, you can see there is definitely going to be a difference here. So you can determine the how large of a range you need to study by doing a few preliminary experiments. So what do we mean? Some rules of thumb are you want to start with feasibility or range finding experiments before the official experiments. You want to determine what factors are reasonable, what levels are reasonable, and how much variation is inherent in the experiment. Oftentimes, it's recommended that you split your experimental resources, that is, your time and your effort, and so on, and spend no more than about 25% of them on these pilot runs. And then the rest of your time and effort, 75% or more, on the actual final experiments. Now, the procedure that you can use standard literature procedures. And again, you find these out from your initial background reference or from mentors or your teachers. And you should test them out with some knowns to qualify the experiment. That's also how you determine an idea of your accuracy and precision. You can also try to invent your own procedure. And the judge will generally give you some kudos for originality, but you need to be aware of lurking variables, things that you're not aware of. Are you really measuring what you think you're measuring? So in order to do that, again, you need to compare to standard procedures and test out with knowns. Finally, you need to analyze the data. Analysis, okay? Tables and graphs help you with the analysis. You also need to communicate your results, and by that I mean communicate it to the judges. For each table or graph, you should be able to articulate a question, and the questions should be answered by studying the graph. Now, you want to make your table and graph very simple and such that the answer will just pop out. You don't want to have your judges have to spend a lot of time in order to figure out what you've actually measured. So again, not making your display pretty or eye-catching is not what you want. You don't want to worry about making it pretty or eye-catching. You want it to stand out and to be able to for the judges to know exactly what you've done and how that relates to your hypothesis. Well, thank you very much for your time, and I hope you have a wonderful science fair. I hope you enjoy doing your science project.